Let's do a few more exercises involving lambda expressions to prepare ourselves for that classic exam question for this part of the course, which is, here is a function that takes a vector and it takes a function object, which takes one element, and this all the function does is it iterates over the vector and calls the function you provided on each element. And then your task is to implement something without using any loops. Now, you may not specifically be given for each on an exam. You could be given something similar like accumulate, something that does an operation involving loops. And then you are expected to implement whatever the task is without using any loops yourself. So when you need a loop, you have to call the function you're given. So in this case, the for each function. I want to go through a few exercises that do that. Now, actually, all of these, in a sense, are takeoffs on things we went through in the previous video. At least one is pretty much the same. But in the event you just want to see the practice and not all of the exposition, I figured having this other video might be helpful. Okay, so task number one. I guess I should run the code as it's currently written. It currently contains all sorts of loops that we have to remove. Okay, so it prints out first off, it takes this vector v, it adds everything up into this variable called sum, and then it prints out the sum, and that sum is 600. So we'll start with that. Okay, so I have to rewrite this to use no loops. So if I want a loop, I need that for each function from up above. And the for each function takes the vector, and it takes a function that gets called on each element. And the function that I have to pass in will return void. All right, so I guess what I want is, we'll just call this add to sum. I'm going to write a lambda expression that captures the variable sum because I want to modify the sum as I increase it for each element that was provided. So I take an int, and then my lambda expression inside the lambda function, all I really do is I just say sum plus equals x. And so the key thing there is that I write a lambda expression, and then also I don't get ahead of myself. I remember to call for each. I constantly make this mistake where I get so wrapped up in how excited I am with lambda expressions that I forget to actually use the lambda expression for anything. And on an exam, you would have to lose marks for not having this. And then I also make sure that anything that I borrow from the outside scope that I modify in the lambda expression must be captured somehow. I like to do all of my capturing explicitly. Although you can get away with this on an exam, I strongly prefer this, where I say specifically what variables do I need. I list all of them. All right, so we'll try that out. We can observe there are no longer any loops where the task previously was located in main. The for each function contains a loop, but we're allowed to call the for each function. And there it is, the sum is still 600. Okay, what's task number two? Well, there's these two other functions. So this function, add x, takes a vector and then returns a new vector resulting from adding the element you provide to every element of the vector that was given. And so that would be this. So you give me a vector, you give me an element, I will make you a brand new vector where I just add the element, the value x that you provided to every element of the vector that was given. So task two is rewrite this to use no loops. Okay, so there's a few ways of doing this. In this case, because of the way the for each function is written, my lambda has to return void. And that does sort of pigeonhole me a bit, which is good because it means I don't have to worry about weighing different options. I'm just going to call this F, actually. I can't think of a good name for it. So what I want to do is I want to basically do the internal part of the loop inside my lambda expression. So I'm going to need to borrow the result vector from the outside scope. And then I'm going to call it element this time to match up with what my for each loop is doing. Okay, and then inside the lambda expression, I just include the contents of the for each loop. So element plus x. There we go. And that might be all I need to do. So we'll take a look at that. Wait, I guess I almost made the mistake I just talked about. I got so excited with the lambda that I actually forgot to call for each. So of course, all this does is make a function. It doesn't actually use the function. The for each function does that for me. So I have to make sure I call it. So we'll try that. All right, so now it says x is not captured. That's a good point. I actually forgot about that. So I'm borrowing my result vector, but inside of my lambda expression, I'm not just using the parameter that was passed by the for each function, element. I'm not just using the result vector, which I already captured. I'm also using this value x that was passed in. And this is a member of the enclosing scope, the scope of the add x function. But I didn't capture it. Now I don't need to modify it, so I'm going to capture it by value. I'm not going to do ampersand x. But that is, I did actually miss I actually missed the capturing of x. Okay, so we do that. Now I did capture it, and so we'll try lambda exercises again, and we can see the result is still the same. So the vector had 100, 200, 300, and when it comes out, it has 106, 206, 306. So I think I've completed task number 2. And then what's down at the bottom is just a call to this print vector function. That's what's printing out 106, 206, 306. Task number 3 is to re-implement the print vector function to not use any loops. Okay, so this will actually be a little bit easier. So I'm also going to call this I guess I can call it print element. Okay, so I'm going to make a lambda. I'm going to take a single element. Maybe we'll still call that element. And then I'm going to print it out. And I don't think I need much else. I don't need to borrow anything from the outside scope because all I do is print the element. It's worth actually considering what cout status is here. Cout is a variable, but it's a global variable. So although cout, technically speaking, is something you can access from inside this scope of print vector, because it's a global variable, you don't have to capture it. It's assumed that lambda expressions always have access to global variables. That is why I'm allowed to use cout without needing to put it in the capturing clause. And in general, I only need to capture something if it's in a local scope of some kind, not a global scope. And so I'm allowed to just write this, and then of course remember to call the for each function. So I for each with v, and then print my print element lambda expression. There we go, and so we'll try that. And it still works. Okay, so I've now rewritten all of these functions to use no actual loops. They delegate all of their looping to this function for each. And a typical exam question gives you something like this, so maybe not for each. It does some sort of loop-related behavior, and you are told in your solution you are not allowed to write any loops of your own. You can use whatever other functionality you want unless it forbids anything else. So for example, I could use functional features like lambda expressions and then delegate to for each. And it's true that compared to a regular for each loop, a lot of these are a bit more bulky. And that's true of a lot of features we've seen. Not every technique works for everything. I think we have proven the point that lambda expressions can be really helpful. And if we haven't, we're about to in the next couple of videos. But certainly we've demonstrated that we can use that lambda expressions are powerful. They can duplicate a lot of the things we would otherwise use loops for. And maybe a for each loop over a vector is so simple that of course you'd just write that. But I can produce iteration exercises where you would much rather call a function with a lambda expression than do the iteration yourself.